Hey guys, in this video, we'll be going over how we can make this top-down camera pawn in Unreal Engine 5.5. And we've also set up bound limitation. That's the camera will not be able to move out of the boundary. And also we have set up return to origin. And yeah, let's dive right in. So the first thing that you need to do is to create enhanced input action for WASD on the keyboard as well as back to origin. And after all, you want to set up an IMC mapping context, input mapping context to include each single of them. So let's go over camera move. This is the most important one. It is the same one as the I believe it was IA move from third person template. This IA move I was using is from the game animation what is called GDC motion matching project. Basically you just copy this, paste it into your own file, then rename it to camera movement so you know what it is. Then you want to create the back to origin. So my idea of back to origin was I want to press C, then it would reset, basically set actual location of the camera back to 000, right? The world origin with an offset of z-axis. So the camera would be up in the sky, and nothing should be changed. Pressed 0.5, and you want to set the key mapping in the IMC camera movement. WASD for, let me see the modifier. So for W and S, you wanted to inherit, you want to include the swizzle input access value for W and S, and for S you want to add the negate, and for A and D, I believe A is negate as well. So what negate does is that normally it's the output should be 0 or 1, right? 1 being successful, 0 being nothing happens, and negate would change that 1 to -1. So the engine knows that you are going into the negative direction, right? So in our context, A is going to the left and D is going to the right. So apparently D has no modifier at all, and S is negate, N is going down, S is going down, and W is going up. Copy paste off this, the mostly the modifier, and nothing else is different. So once you have that set up, you want to add the context. You want to add the mapping context. I implemented in the get mode, and we call a function called setup input. So what it does is that you want to get your player controller, cast it, and make sure that you add the mapping context. In my scenario, that only one mapping context is used for our top-down level, so the priority doesn't really matter, but you would always want to set it as high as possible because you want it to basically take priority. It will consume first, the higher the priority it was. Then you want to create a blueprint of a character class. So basically you want to go to blueprint, we'll go to character, we can call this BP camera pawn 2, right? So you will open this up, it will look like this. What you want to do is that you want to add a spring arm, and then you want to add a camera, sound like that, and you want to make sure that the camera is below is the child class of spring arm. Then we don't really need to necessarily manipulate the angle or the distance in here because we would also be able to do it in the game mode. So what I did here is that at the event begin play of the game mode, we get a player pawn, and we basically recorded the initial camera height and as well as the camera pitch, basically the angle into our game mode. And I used the timeline. The timeline is to basically have a smooth transition from ground up, from 0 to 1, 0 to 3, and where's it at? And then we multiply it by the initial camera height, plug it into the set actor location, as well as the camera pitch into Y. And somehow when my parent class was pawn, it did not move at all. But once I switched to character with this character movement component, it just works. And I would recommend you to like test it out first. So basically, you want to like once you press trigger, you want to like print a string first. That's what I would do, so you know when it will trigger and when it will not, like I did for the complete, right? Okay, so the next thing is that you want to create the camera pawn. The parent class can be either pawn or character, but in my case, I found out that character movement is one of the best way to implement movement. Because when you create a BP pawn, it doesn't come with it. Let me show you what I mean. So when you create a pawn, it doesn't come with the character movement, and in fact, it doesn't even allow you to have a character movement. So what you really need to do is that to change the parent class from pawn to character, right? So therefore, it just automatically gives you a character movement, and because of that, you are able to use I think it was called add what is it called? Add something input. Let me see where it is at. I think it was this one. Add movement input. Okay, so now let's talk about what we got, like the output of this enhanced movement camera move once it detects the player press WASD, right? So it will give out, it have the pin, it has an output, right? It has a parameter or whatever you want to call it of action value, and it's a vector 2D. So what it gives you is basically two values, but you can also think as two like graphs, like x axis as well as y axis, right? So you want to plug an x into. Okay, so what we did here is that we add movement input two times, one time for the x and one time for the y. Get forward vector as well as right vector, plug into the yar, so it knows that one is x and one is z. I think this is the really elegant way to do this. Then you plug it into add movement input of the world direction, and you put the add movement input, put the x, plug the x into the top one, and also plug the y into the bottom one. You can switch it around, but you can like do something like this, and then you can plug this to the bottom, and you can plug the y to the top. It will be doing the same thing, but oh yeah, and also for this functionality, for the get movement input scale value, you would have to create it yourself and make it a pure value basically. And then you want to normalize the action value. Even I do believe that the action value always output -1 to 0 to 1. But just in case, I still used normalized 2D to make sure it's clamped within -1 and 1. So after you finish implementing the camera move of the enhanced input action, IA camera move, you should be able to move the camera around. But the thing is that your camera will be extremely slow because the movement acceleration is controlled by the character movement. What I did here is absolutely maximize the acceleration to an extremely high value, right? So what it comes with is 2048. So that's the maximum acceleration. And if we play test it, you can see that I am holding the S key and it's just extremely slow. And it sort of have like this feeling of acceleration or inertia when you press auto key, when you press S and D together, or like A and S together, it doesn't stop automatically, right? And this So what you just saw when I stop pressing S, so I output it when the input action is complete. So you can see that I'm pressing S right now, and once I stop it, I basically kills all the movement. So that's one of the thing you really need to implement in the in your camera movement. So what I did is remember it's this function. So you want to get the character movement, you want to get this, then you want to call this stop movement immediately function. And in video game, you always feel like that the top-down camera is always moving in a linear type of velocity, right? But in fact, it's not. In this approach, it is not linear. It's following the velocity formula, right? But in order to fake the sense of linear velocity, the method is to give it an extremely high um, acceleration to set up the boundary to make sure that when we move, we don't move out of the boundary. Is quite simple. There are many ways to do it, but I did a really extremely lazy way. Is that I believe I just used two values. Let me see if it's so okay for this function for the clamp within bound. So this is what I did. First of all, you want to set up min bound and also max bound. So in my case, our map is I think it's 10,000 times 10,000. So you should be able to see that the location is negative 5,000, negative 5,000. But the box size is 10K, right? 10K, 10K. And you do a little bit of calculation, you'll get that the lower bound will be negative 5,000, the maximum bound will be 5,000. Or you can, create another functionality that will calculate basically the boundary of your map. But, in our case, we'll be going the easy way. So what this function does, okay, so first of all, you want to think about how do you want the game, the engine, right, the program to know that it is within the bound or without a bound? Do you call it whenever a key is pressed? Do you call it whenever an input action is complete, or do you call it per frame, like a tick, right? I believe it should be called in tick, like in every tick the program should detect that if the camera point is within bound or outside of the bound, right? So, what I wanted is that I want a functionality that always clamps the camera point within the bound. So once it get out of the what's it called? Get out of the boundary, I will basically set it back to where it was at. And in order to achieve that, I used clamp. This is one of the most amazing functionality, mass library from mass library that it has main and max as well as the input value, and it returns output value that is within the main or max. For example, our main is negative 5,000, our max is 5,000. If you give for example, like 6,000, it will output at 5,000 because that's what clamp does. And in our case, that once our camera move out of the bound, for example, I believe that maybe my laptop is extremely laggy, that allowed it to basically get into 5,005, right? Let's say it like that. But once it get over the 5,005, since we are doing it per tick, it will clamp it and give it back and return a 5,000 back to our program. And then we call the set actor transformation. So it's always within the bound. Even when you are out of the bound, it is still within the bound, if that makes sense. Yeah. And then make sure to call it at the event tick. I believe the most optimal way is to maybe set up another function to determine if our camera actor is within the bound. If it's within the bound, do the calculation. If not, just straight up return nothing. Right? I think that would be more efficient on the event tick performance. Okay, so I believe this is all you would need. Yeah, and back to origin. IA back to origin is really simple. You just set the actor location back to where it started. I hope you guys enjoyed it. I know I have been mumbling a lot.